see, we have a question. So before starting the question, I will suggest you to remember these two formulas that will be very useful for our problem solving. One is E equals to K phi omega r, and another one is T equals to K phi IA. So if you don't know these formulas or the basic concepts of the DC machines, I will suggest you to follow one video. I will give the link in the description, or you can see the video up right there. So let's start the question. So here it's asking 250 volt shunt motor has an armature resistance. So at first starting of the question, what information is given? It's a shunt motor of 250 volt. So by reading the question, we'll draw a shunt motor first. So this is our shunt motor. So for shunt, we are making this shunt branch of flux, and we are reading this way. And as this is a motor, there will be a voltage source, obviously. So that will be our VT, and this is our RA, armature resistance. One current will go from the source, that will be IL, and one current will enter here, that will be IA. One current will go there, that is IF, that means flux current, and here will be flux RF, right? And there will be producing EB or EA, so we are calling it EB, right? So this is our shunt motor. Now follow the question carefully. Has an armature resistance of 0.6 ohm. So armature resistance, where this is 0.6 ohm given, right? And field resistance of 250 ohm. Field resistance, where there is field resistance, so this is 250 ohm, right? When driving at 650 rpm, so what is given here? NR is given here. NR is, that means the speed of the rotor is given 650 rpm. So the motor is taking some load and it's rotating at 650 rpm, right? Now a constant, okay, 650 at 650 rpm at constant torque load. That means the load is constant, the load is not changing. So the torque is what? Torque is actually the mechanical load. So the mechanical load is not changing, so the load is constant. Now the armature takes 20 ampere. Armature takes means the IA will take 20 ampere, so IA here is 20 ampere, right? If it is required to raise the speed from 650 rpm to 850 rpm, that means the speed here is NR1, we are taking another speed NR2, that will become 850 later, right? Now the question asked here, what resistance must be inserted in the shunt field circuit assuming linear magnetizing characteristics? So the question asked, what resistance should be added here that will make the EB difference, that will produce the EB difference. Actually this flux is producing the EB, right? So if we add some extra resistance here, then that will cause some change in the EB, that means the back EMF induced here, that will change the rotation, right? Because EB here is proportional to omega r, right? So, and one more thing here, linear magnetizing characteristics. Linear magnetizing characteristics means we have seen the BI curve, BH curve actually, this BH curve. So we have seen the BH curve is like that, but here the linear means the, if we increase the current, and we know this H is proportional to I and this B is proportional to flux. So if we increase the current, with that the flux will also increase. So this is the linear characteristics coming. That means here flux is not constant. Here the flux was constant for ferromagnetic materials, the flux is constant, but here the flux is not constant. We have to assume that, right? So this informations are given. Now we will directly switch to our solution, right? So before solution, our point is see, from here we can see EB1 varies with, see this is constant K, So what it will vary? Phi 1, flux 1, because in the previous case there will be a flux, and in the second case, as we are adding some resistance here, the flux will also change, right? So the flux is varying here, with that the speed is also varying. So this is the equation. And for the second one, EB2 varies as phi to omega r2. So see here, the omega r1, from omega r1 you can write 2 pi in r1 by 60. From omega r2 you can write 2 pi in r2 divided by 60, right? So if we see now EB1 divided by EB2, we are doing this operation, right? So what will happen? Phi 1 divided by phi 2 and omega r1 divided by omega r2. So we are doing this operation here, omega r1 divided by omega r2. So what will happen? Omega r1 divided by omega r2, if we do this, 2 pi will get cancelled and 60 will get cancelled. So the remaining will be nr1 divided by nr2, right? And both the values are known values, nr1 divided by nr2, right? So or EB1 divided by EB2 is equals to phi 1 divided by phi 2 into nr1. What is the value? nr1 650 and nr2 value is 850, right? Okay, now see, one more value is known, that is EB1. How we can calculate EB1? EB1 equals to, see, EB1 equals to, as it is a motor, so minus case will be there, so Vt minus Ia, see, Ia Ra only, right? So Vt minus Ia Ra. So Vt is given see, a 250 volt shunt motor, so Vt is actually 250 volt, right? So write it here, 250 minus Ia is given 20 ampere and Ra is given 0.6 ohm. So 20 into 0.6, that will be 12. So 250 minus 12, 238 volt, right? 238 volt. So we are putting this value here, 238 volt, right? Okay, now another condition is given. See, here is written a constant torque load. So we can see from here the torque is constant. So if we name the first torque is T1, so the T1 torque is varying with phi Ia, right, from this equation, and the second torque is varying with phi Ia. So first one is Ia1 one case and second one is 2 case, right? Now what the question says, it says these both torque are same, T1 equals to T2. That means phi 1 I1 equals to phi 2 Ia2, right? So from here we have to derive something. Let's see, we know Ia1 value. See, Ia1 value is 20 ampere, already given it's. So phi 1 into Ia1 is 20, right, divided by phi 2, that will be Ia2, right? Now one thing, see, these phi values, these phi are varying with If, right? See from here will be the flux phi F, and the flux phi F will vary with If. From here we can calculate the If1. See, phi 1 will vary with If1 and phi 2 will vary If2, right? So this equation can be written further written as If1 divided by If2 into 20, right? That is equals to Ia2. So If1 value, we need If1 value. So If1 value, what will be the value? See here, the terminal voltage, what is the terminal voltage? 250 volt, and 250 volt divided by this resistance 250 ohm, that will give us the IF. So 250 divided by 250 will give us 1 ampere. So IF1 value is 1 ampere, that means 20 into 1 divided by IF2. IF2, see IF2 value, for IF2 value we are considering another circuit. Let's take this same circuit. Let's take for second case the RF is RF2, right? Okay, so the terminal voltage is same, so IF2 will become VT divided by RF2. What is the VT here? 250. So RF2 will go upside, so 20 into RF2 divided by 250. 0 gets cancelled, so actually IA2 equals to 2RF2 divided by 25. That is the value of IA2, right? So this much we have calculated, right? Now okay, now if we form EB2 equation for second case actually. So second case IA2 is known, right? And the RA will be same. Armature circuit is not going to change, right? So EB2 equals to, we can write VT is also before, same as before. So 250 minus IA, what is IA? 2RF2 divided by 25. So IA2 RA, right? So RA value is 0.6. Okay. Now EB1 is known, EB2 is known. What we have to calculate? So if we use this equation, from this equation we can find out something. See, here EB1 value is 238 volt, 238. EB2 value is 250 minus 0.6 into 2, that means 1.2 RF2 divided by 25, and that is equals to 5152. I have told you before, 51 means IF1 divided by IF2 into 650 divided by 850, right? And IF1 value is IF1. See, IF1 value is here 1 ampere. IF1 value is 1 ampere, so this will be 1 only. And IF2 value is calculated here. Where is IF2? IF2 is VT by RF2. See, VT by RF2, IF2 means, okay. So if we write here VT by RF2, the RF2 will go upside here, and here will be VT only, right? And the VT is 250, right? VT is 250. So overall the equation will become 238 divided by 250 minus 1.2 RF2 divided by 25 equals to RF divided by 250 into 650 divided by 850. And if you calculate this, after calculation you will get the RF as RF2 actually. RF2 will get 30. Right, this much we will get. So the question here asked, what resistance must be inserted in the shunt field? That means the RF2 is the total resistance we have taken in the second case. That means if we subtract this RF from RF2, that means RF1 from RF2, that will give us the answer. So RF2 minus RF1 equals to 331.25 minus 250, that will become 81.25 ohm. That will be your answer.